Well, thank you, Karina. This is a really nice space here. Great food. I am not going to eat during this, so it could get messy if I did. But let's begin. So I'm here to talk about kind of a systems engineering concept of fault trees, and I'm going to try to take that through more of a business tech thing called SLOs, service level objectives, and then I'm going to try to show how at my former employer Nordstrom we were starting to work on a way to transform those two into monitors that we can look at in Datadog, things that we can use to get a good idea of how our stuff's doing and not over alert, not experience alert fatigue, and yet have great awareness and situational observability. So, oh yeah, I need to use my phone. This is cool. There's a little Keynote manual or a Keynote remote you can use. So I can do this away from my computer. This is fun. So, I think everybody here cares about systems, right? We all probably work at a company that operates some technical machinery or code, and it produces a service that somebody consumes for money. So we have an interest in making sure our systems are working. And general true thing is that your systems are only as good as your components that you make that system up of. Another thing to note is that it's also their arrangement. So if you have just one little thing sitting there, it's your single point of failure, right? If you have many things in parallel, you might have an option to go another route. You have another chance to succeed. So fault trees are something I took from my previous experience with aerospace, where we looked at what's the chance that an airplane is going to run off the runway. And we looked at all the different things that could cause that to happen. And you start quantifying the probability of each of those little things, and you combine them all together using some fancy math, and you come up with what's your reliability at the end. What's your chance that you're going to run off the runway? So the basic way to think about fault trees is in serial and parallel. The way you architect your system, you've seen it. When you have horizontal scaling, when you have many workers or a high availability cluster, you have parallelism. Whenever you're depending on a single database, you've got a serial connection to some component in your system. The thing about serial connections is that they're always going to lower your reliability. If both of these things don't work, or if either one of these don't work, your system doesn't work. There's no other route I can take to make this thing work. If B is down, that's all there is to it. And the way that's expressed in some of the systems engineering disciplines is that you've got probabilities of failure adding together. So say you have a 1% chance of A failing and a 1% chance of B failing. The chance of your entire system failing is 2%. It's pretty easy to grasp. Parallel. Usually, and I put an asterisk here, almost always, whenever you have parallel paths or redundancy, you have a better chance, a higher reliability than each of those individual components. I put a star there because sometimes there's a common failure root cause to a set of components that are in parallel. They're all doing the same job. You could have a bunch of workers in a data center on a node or in a cluster. You could have them in a cloud, in a VPC, wherever you have them. And if they're all failing because of some root cause underneath that, say it's your DNS. But we'll talk about that later. That's another issue. We can actually quantify the DNS reliability and factor that out. But sometimes maybe there's a code change. Say you roll out the same bit of code to all your nodes at once, and you go full blue-green. Now you still have many things in parallel working together, but they all share a common failure point. That's one of the things that gives rise to concepts like canary deployments, where you have a slow roll-in of traffic to a different code base, a different deployment you have. And that's one way to manage reliability. This is not as complex as that. This is merely looking at, hey, I know that I have maybe a hard drive. Maybe I'll go down all the way to the hardware level and I'll say, I have hard drives that have a reliability, a pretty well understood reliability of they fail once every 10,000 hours. I can take a couple of those, put them in parallel, like RAID, like ZFS, and I can take my probabilities of failure and I can multiply them together. And if you remember a little bit of math, when you multiply a number that's less than 1 by another number, you're going to get a lower number than that other number. So if you take 0.1 multiplied by 0.1, you get 0.01. So why are we talking about these fault trees and fancy logic math? Well, I want to bring into this conversation something else that is important to our businesses and to our operations. Our bottom line is our service level objectives. So how this fits in is that we have a service level asterisk. You've probably heard these or seen these around: service level agreement, service level objective, and service level indicator. So you have at the very top of it all, you have some customer, some consumer of your service or your system, some user of your system. And you're going to give that user an SLA. You're going to give them an assurance that you're going to be up 99.9999979 you're going to have a reliability of 9 nines or something like that with S3. So you're going to take that assurance and you're going to try to somehow come up with individual strategic objectives, right? You're going to say, well, for me to get that 99.9 whatever, I'm going to have this in place. I'm going to have each of my little components in that system up a certain amount of time. And then the indicators, the SLIs, are the individual metrics. They're going to give you that indication. They're going to tell you that, hey, your box is up. Your server is responding to traffic. Your database has additional connections available in its pool. Again, this is specific measures of a system's performance. That's what we're looking at here with SLOs. And an important factor to think about is that this is best measured by the end user. It's, in most cases, when we're dealing with metrics and metrics gathering, we're doing it right on either the hardware or the software with software, and we're sending it to some central location where it's aggregated, and you can take that data and look at it. You can set monitors up, you can graph it, you can watch it on a screen. But really, some of those things may not give you the full picture. Maybe they're not quite measuring that full end user experience, and you're missing maybe a little bit of latency that was hidden. So one of the things that this brings us to in our experience at Nordstrom was we started really hitting the synthetic monitoring aspect of things. So that's where several vendors can do that. Just wanted to mention that as an aside. So let's go through thinking about an SLO. So here's something I want to say. I want to have a service that can claim 99% availability. So conversely, that means that it's allowed to be down 1% of the time. Here's a basic architecture diagram. I took this from Artifactory's high availability layout. It's very simple. And then I just kind of, neutered it, turned it into a very bland example here. But it's something you've probably seen before if you're designing systems for high availability, if you're deploying things to Kubernetes. You basically have a way that a customer can look up your address, your website, your service. You have a load balancer that allows you to parallelize the work and the load. And then you have a server and an app. For the discussion here, I'm going to consider the server and the app, each one of these pieces here, as one component. Maybe you have a front-end server like Nginx, and then you have some other back-end that's pumping out some web content that you're serving. But I'm going to consider that one little item. That'll be the probability of the app to fail. And then I'm going to look at my VPC. This was called network in the Artifactory example. But I'm going to say, hey, we're just putting this in AWS. So I have a VPC that's configured to route traffic to an RDS. So it's a relational database. That's just a way to store state, And S3, another thing to store objects. Sometimes you might use it for state. But you have storage. You have two different types of storage. They are used for different things, and so they are not parallel. Even though they look like they're parallel here, they're actually two other segments in a serial equation here. I try not to make this too dry, but basically we're looking at a system here that adds up all of the probabilities of failure of all those components in serial. So that's the DNS, the load balancer, the app, and when I say app here, I mean this entire 6 boxes. And we'll go over that in a second. The VPC, the S3 bucket, and RDS. Okay, getting a little deeper here, let's look at this. All right, so we're saying this is our equation. We're saying we're targeting 99% uptime, so that's a P system of 0.01. Well, if I start substituting things in here, I'm going to take some of the SLAs that S3 can give me, that Amazon can give me with their RDS. I'm going to start saying, hey, things like the network, the VPC, unless someone's done anything to that, if it's working now, it'll work later. I could almost consider that 0. Maybe not. These are all design considerations that you get to make for yourself. And you can also test them, right? You can look at things and you can use some historical experience to say, are my assumptions right here? But what I'm trying to do here is I'm trying to show how maybe by using some other services that have SLAs of their own, you can start factoring this down to one component. And that's going to be my app. And we're going to focus in on what's your app's reliability and how can you do anything about it. So when things aren't in parallel, when you have a workload and there's a single point of failure, there's a single worker doing that job, that app, in this case, needs to have 99% uptime. It basically has to meet the exact assurance that you're giving for your entire service. I don't know, do folks here feel like there's any app in a single instance that would have that assurance? Probably not. Low power mode. Like, so if you run for a month and it fails for, a couple hours.
Just a couple hours?
Yeah, I actually am not doing the math well in my head, but what's 99% of 30 days? It depends on how good you write your code, right? So we got the robustness of parallelism. Now I start saying I'm going to make a couple replicas, and that's going to be a tough app. That's going to be a little bit more resilient. I mean, this is a practice we use all the time, but I'm just trying to give you a little bit of what the computational background is. So we can scale out. Let's go up to 2 nodes. If I take the square root of 0.01, I can get 0.1. What's that say? That means, hey, those apps only need to be 90% up. I just shaved 9% off of my reliability, what I need to have. I can have an app that's not as reliable. I can relax a bit more, add 3. And now I don't even have to be 80% up. If I wanted to go to 10, I can just relax, take it easy. These apps could only be up 63% of the time. And they'd be just fine. Your service, if there's no common root cause to your apps, should be just fine. You'll be meeting that 99% availability. Okay, so we've talked about looking at your system design and trying to get a little computational about it. Well, okay, that's fine. But how's that going to help us in our operational world, in our operational life? Well, monitoring, I'm sure we're all familiar with that. It's where you're taking a look at your system, you're taking a look at indicators, and you're saying, am I healthy? Am I good? Is something broken? And maybe if something's broken, I look into logs or traces and I see what it is that's broken exactly, and I can start to fix it. And I can wait till that monitoring signal that says something's broken goes away, or it returns to normal, or it returns to a place I want it to be. In our experience, in my experience, for a short year at Nordstrom, really, and I think this is a lot of places, there were sprawling monitors and dashboards. There were things created willy-nilly Sometimes a dashboard would be valid today, and then 3 months or a couple weeks later it'd be sort of out of date, stale. And what you find yourself in is you get into this overdrive, this mental alert fatigue. It happens in hospitals all the time. It can happen in the cockpit of an airplane. It can happen while you're riding your bike down the street and watching out for other pedestrians and cars. And you start to zone out or tunnel vision in, or you just start to blank out and you don't see anything. Either way, what you're doing is you're missing the important signals. This is bad. And worst of all, those of us that get paged a lot. And maybe we're getting paged 300 times in an hour. I heard my new boss at my new company just said he woke up for about 300 pages in an hour because alerts were misconfigured. There was a little bit too much granularity. Every little thing that failed just spat out its own little alert, and it was all hooked up to a page policy. Ouch. Let's bring it back and say, you know what, for sanity's sake, let's alert when an SLO, something we think is a critical piece to our service meeting its assurance, let's alert on that. And even better, if you can tell me what's contributing to that, then I have a better chance of solving it. Because one of the things I don't go into here is that it's a little more complex than your probability of failure, right? It's also about how quickly you can recover. I think that's part of the DevOps practice is that yes, you fail forward, but you have to know how to recover quickly. You have to know how to roll out your A or your B or your green or your blue, and you have to be able to roll back if things don't go well. Or if you're doing a canary deployment, you start sending some traffic there, and as soon as things look like they're going sideways, you pull that traffic back and you revert back to your last known best state. In our time going through all the weird late shifts in the operations center, I started thinking a lot more about stale data, stale monitors, stale dashboards. I started thinking a lot about what are those key SLOs, what are those metrics we really care about, that we really want to look at. And I also started thinking about, hey, I remember engineering at an aerospace company where you'd have design documents. You'd have things that you said, this is what makes my system work. This is how it's put together. Anybody that can access those drawings or those documents can go to your thing, your system, your component, and they can look at the drawing and they can look at your thing. And they can say, yep, it's according to drawing, good to go. Or it's not. Maybe something's off. Or maybe something's changed because you thought something would be better, but you didn't let anybody know. You've deviated from your engineering. We live in a technological world. This sector is all about quick change. The business opportunities go by quickly. I can understand the need and the desire to just go cowboy and make changes, make things happen. It happens in operations all the time. You need to get it fixed, you need to keep making money. So you do something, you start deviating, you start sliding away, drifting away from what you originally designed. So I decided, hey, it's time to come up with a design document for a service. So this is your basis for claiming that your service is meeting an SLA. And also, more importantly, for operations folks, it's a template for observability. And the app I started developing there with some other folks was a way to take a drawing or a YAML file, which I got my inspiration from Kubernetes and some of the other things that love YAML files. And I said, let's turn that into monitors. Oh, there we go. So again, I said this already, but you want to have your production configuration match your engineering. You want to update your engineering if you want to change what you're putting out there. And I like to think about this pool idea, this pool concept. You play pool for money, you got to call your shots. And that's kind of what I'm saying to the culture, is that go ahead, do something cool, make it awesome, but call your shots and let people know what you're doing. And you're going to publish this in a place that people can find. If someone else is going to be troubleshooting your app or your service, which happens. You know, DevOps, we're not at full 100% DevOps perfection, where everybody that writes their code is also operating and receiving pages. Or even if you are, maybe you didn't write that function, you didn't write that aspect, you weren't there for that. You should, as a person that's responding to an issue, be able to go reference what that system's supposed to do. All right. So I'm looking at monitoring and I'm saying, all right, let's turn this into infrastructure as code. We first started with monitoring in the UI, right? You go into Datadog, for example, and you can pull up a place to start to create monitors. And you can start picking your metrics and you add them in there. And you may be missing all sorts of things. Well, how about we start using some code? That was our first iteration with this program, was we said, all right, let me get this little document, I'm gonna pump it through this code, and it's gonna go talk to the API, the Datadog API, and it's gonna make monitors there. But now all of a sudden, I'm looking at having my code, my service, being the only way we create monitors, if you wanna use it. So it's a single point of failure. How about what I do is I create an app that pumps out Terraform, infrastructure as code, and that infrastructure as code is going to write up and manage these monitors. One of the best practices I saw at Nordstrom was when folks would put their monitors in Terraform in their code base. So whenever they were writing their code, they could share variable names, they could share outputs and inputs with their monitoring. It also increased the chances that those monitors and those views into what their code was doing, their service was doing, would get updated with the code. You could even write tests that would make sure that's happening. So, codename Kali. I don't know what to call this little code. I kind of left it at Nordstrom. I may re-envision it at a later date, but for those that like regular math, sort of SLA plus architecture turns into monitors. And for those functional folks out there, so here's a top-level view of what I envisioned was the base minimum that you could put down for your service. I wanted something that was terse, that was succinct, that didn't do a lot of repeating, and so I kind of got into this hierarchical way of thinking. So if you walk down this system, we want to know the name, we want to know the ID. These are later going to be turned into tags. And I'm going to tag every monitor that comes out of this process. So that later on, when I use Datadog, I can use tags to very quickly scope to just those monitors. I can very quickly query on those things and get a summary of how that service is doing. Without really having to build too much, I could just use a couple tags. Contact. So, who do you wake up? Who do you Slack? What channel do you talk to? SLA. These items down here are maps. I'm going to go into them deeper. These are nested constructs down here. The SLA is going to contain some more things about, hey, what are you saying you're going to claim? Are you going to have a latency claim? Are you going to have an uptime claim? What have you. We'll have some monitor tags. This is where you have the option to put in X number of tags, whatever you want. And then you have your components. And the components is where a lot of the meat of this happens. So here's an example. Here's a system. I'm going to name it our app. I'll give it an ID number. And here's a contact. I want you to page, if and when you're going to page this PagerDuty policy. And if you need to talk to somebody because you see this alerts going off, here's a Slack channel where you can reach out for operational support from that team. Here's a sample of an SLA stanza, I could call it, I guess. So I'm just making some random claims here. I'm saying I have some latency claims. I'm saying 90% of the time I'm going to give my end user a 200 millisecond latency. That's going to be pretty snappy. And only 1% of the time I'm going to have greater than 500 milliseconds. I'm going to have an error rate of 1%. I kind of was thinking about this one, the saturation is kind of funny, 80% CPU. I don't know. Maybe there's something better you could claim for saturation, but I'm trying to look at the golden metrics, things that in the observability world, in the SRE book, they say, hey, if you look at your errors, your throughput, your latency, and your saturation, and you got those bases covered, you have pretty much everything you need to know about your system and how it's performing. Here's a place that you can put in top level tags. I'm just saying, you know what? All these monitors that you see in Datadog when you go through the monitor screen, they're all gonna have this tag. So you know that they're managed or generated by this software. You can add all sorts of different things in there. Oh yes, and as I said, the application name and ID, you don't need to add that in here. That's gonna be part of what the code puts in there for you. Again, I'm trying to use dry principles where I'm not repeating a lot of data, a lot of information. Say it once, don't make this a chore for people to do. Because the hardest thing about getting adoption is if you make a tool too hard to use or too tedious to use. If it's adding toil, it won't be adopted. All right, here's where we get into more of the meat of it. Here's a load balancer in AWS, and here's some monitors, or a monitor, that I want attached to that. So this is a hierarchical thing, right? So this component is part of this service, and this monitor is part of this component in this service. So my code was attempting to essentially walk the tree. Walk the tree, and for every single monitor, I'm going to pull in whatever component that was for, and I'm going to reference back to the service. And then I'm going to use all of that data to come up with something that says, all right, my error rate, my 500 HTTP response code error rate for this load balancer is not going to go over 1% longer than 20 minutes, or else I'm going to get paged. The tags here are not tags that get applied to the monitor. These are filter tags. These are tags that are associated with that component. This is not enough to make a monitor. This type, aws.elb, I kind of envisioned sort of a community repo, a modular repo where you could say, maybe even versioned, where you could say, here's our best template for an AWS ELB. Here's what we think makes a Datadog monitor for an ELB appropriate. And you supply a couple little inputs and hide the rest of all the nitty-gritties of setting up that monitor, right? There's all sorts of other settings in a monitor that maybe you don't really need to worry about. Maybe there's a best practice for an ELB, and maybe what you can do is come up with different iterations of that, different versions of that, and see which one you like. See which ones you think are better. And if you want to tweak it, then you recommit it back to another code base, and other people can use that. In the end, the hope is that you have monitors that are only enough monitors that you have SLOs. You don't have a profuse proliferation of monitors that have a dubious meaning or a dubious use. You have a reference to an architecture document, so if that monitor goes off, you can take a look and learn more about what's going on, what you should be expecting to see. You can investigate it as an operations folks, and then you have tiered comms and paging, and I guess what I'm saying there is that not everything has to page you, right? You can set up certain criticality for certain monitors and certain SLOs. You can say, you know what, I do want a monitor to trip when one worker goes down, but I don't want that monitor to page anybody. I'm gonna maybe make another monitor that alerts and pages you when all of them go down, or 80% of them go down. But you can rationalize what you want. I wanted to get a little snapshot of the composite monitors, but I didn't get a chance to put that in there. This is a feature in Datadog that I really liked, although there are some limitations with it. It's a great way of taking smaller components, just like we're talking about here, and we're comprising a larger thing that boils things down and maybe simplifies things, right? Instead of having 20 monitors or 3,000 monitors, maybe you could stack those all up so that you have 10 monitors. All that you're looking at, and you're putting that on your single pane of glass. You still have those 3,000 monitors out there, and they're all looking at their individual components. They're all meaningful. but they're more meaningful when they're categorized up in a tree that reflects the system's design. You also have a way of, say, using your tags. Maybe the monitors I tag, they're also going to get tagged with the golden metric they're looking at. I'm going to tag them with golden metric latency, golden metric throughput. So now I can very quickly create a bunch of programmatically composite monitors that take for a system all of the latency metrics and make a composite monitor of that. So I can get a top-level latency view on my system. And it should ease alerting. That's kind of where I was going before, is that if you get alerted by one alert, and then you see this big tree of all the problems that it has, it might be able to at least wake you up once and give you a good picture of what's going on. Oh yeah, I did find a little snippet. This is one view on a little composite monitor. Maybe now's a good time to talk about some of the limitations I see with Datadog's composite monitors. Is that you can only use 10, and you can't stack them. You can't take a composite monitor and use it in another composite monitor. I'm sure there's some technical reason for that, but I also think that technical challenge could be surmounted. And it could help us reflect our system design in a monitor itself. I think I've already said that a bunch of times. So culture, how are you going to make this actually happen? You know, this is cool on a slide. That's cool to me, maybe some of my friends, but how this gets into our culture is we should really start doing more peer reviews. I've heard a lot of times that what's one of the best things that we can do is to co-pair or pair code, co-hack. Adrian loves that one. I love co-hacking with Adrian. And peer review, code inspection. These are all super basic things that are very human that we can do. They're not technical, they're not fancy. But that's what this espouses, is you're saying, here's my design document, let's look at it. Here's my design of my system. If you want to change it, let's talk about what we're changing. And we'll rationalize it. The other thing about it is that a design document like this, you can put it into a code repo. You can put it in version control. And you can start looking at the changes you're making and being rational about them. I don't know how much I want to go into all this, but getting failure rates and reliability numbers, that's hard. It's costly. You know, aerospace folks, they spend millions and millions of dollars and years testing things, because that's the only way you can really find out how reliable something is. One thing to think about that is, well, why not use another service? Why not, you know, here's my pitch for using SaaS or something else like that, is that you can let someone else deal with making sure their thing is reliable, and you just kind of piggyback on that. And you can start to factor out some of that challenge of knowing what it is. What we deploy is constantly evolving. You know, yeah, real engineering where people are, you know, flying or going over bridges, it's slow. It's slow because it's got a lot of risk. In the world we're in with tech, it's not as risky. It's getting there, but it's not as risky. So we have the freedom to fail a little more. So this is kind of a challenge, right? Is what's the right balance between taking our time and being methodical and just, you know, shooting from the hip and making things happen that are really cool, capitalizing on the market and making money. But hey, part of this talk is just saying, hey, you know, there's some real benefits you get when you parallelize. And my new job is interesting. The manager kind of blew my mind because he said, let's decouple. Let's take our systems, decouple them, turn our dependencies into adjacencies and go for this eventual consistency thing, which if you studied S3, it's what it's all built on. Things to think about. Suggestions I might have, you know, start with your business objectives. I know we like to code. We don't want to think about business necessarily, but it is important. It's important to know what you're being held to, what your expectations are, right? If you can meet your expectations, you can basically say, boss, leave me alone. I'm good. Look, see, I'm meeting your requirements. Yeah. Oh, and then infra as code. I was just watching the Yevgeny Brickman talk where he goes over the whole infra as code thing as he sees it from Gruntworks, and it was pretty interesting. You can do integration testing with your infrastructure as code. It's something that's a little challenging because it's integration testing. You're actually standing things up in the cloud somewhere, and you're actually trying to send payloads to it, or tests to it, or maybe just API calls on the side. And you're trying to validate that it's there and that it's working. That way, you can start to factor out those things like the VPC setup. If you can set it up right and you can test it, unless someone changes it, it's probably not going to break. And you can worry about making your app the really interesting code. You can focus on making that more reliable. And I already talked about this, some ideas, complex monitors that are wide and deep, and maybe even like a visualization. So we got into service maps a lot. I wish I had more pictures, but a service map's a beautiful thing, especially if it has some color coding and status indication on it. If you had a picture of all your dependencies of all your code and all your systems, and each one of those had connections and they had little lights that told you when something was wrong, and then it bubbled up the chain, you could start going through that and you could say, well, let's go to the root cause. I can visually see what the root cause is. I can see where that red starts, and I can start attacking that first, and then I can slowly clear it. If I clear that root cause and then it still remains that these other components are problems, then you go to them. And you methodically work your way through it instead of spending 10 hours guessing at something. That's really all I have. So I'd love to hear people's questions, any ideas, any thoughts you have about anything, really.
That was great. I have just a quick question. So you built that service that like kind of takes a YAML file and they define some of their objectives and stuff like that. And
Yes.
built Terraform Code.
Right.
What was your thought there versus just using modules?
Right. My thought there mainly was that modules are great. I think if a team is at that level where they're using modules and they're making their infrastructure as code in their repo, I saw that and I loved it. And I said, that's why I don't want this to be the only way this happens. But I do want to give teams that don't have that maturity a way to jump into this. To say, write down some basics about your service, things you should be able to write down if you're designing a service, and I'll give you a bunch of monitors you can start with. Then you can decide on how you want to go from there. The other thing was that I wanted that document, that design document. You know, inspection of code, looking at how people do their modular deployment of Datadog monitors. It's very cool, but it's a little harder to read. It takes a little bit of time to go through it. If you're in an operational situation, it's kind of nice to see something that summarizes, gives you like a synopsis of your service. That was my thought.
Two questions. One, could you repeat what you just said so that I can remember what you said later when I edit the video?
What he said. Oh yeah. Why didn't you consider using modules for your infrastructure as code?
Awesome. And,
Did I get that right?
yeah.
Okay. I could be like a politician. I could just answer whatever question I want you to have asked me.
The other thing I was just going to ask, did you get to use Terraform from Yevgeny?
No.
Remember if that's his name.
That is what's on the menu
Yeah.
for where I'm going now. Yeah.
Cool.
Yeah.
I'm going to repeat that question off.
So yeah, Terraform. Well, the thing there is that where I'm at, we're doing a lot of glue. The glue is oozing out. The bash, right? To try to deal with bootstrapping accounts from an AWS organization and trying to get all of those different environments stood up and then their own state in their account that you then throw things on top. And if you try to do that with Terraform doesn't do well with multiple states unless they're data sources. It doesn't do well unless you use like workspaces or if you use some bash glue to have it say like go into a directory as a root module and then deploy from there and then back out, go to the next one, iteratively down your row of environments you want to stand up. TerraGrunt, from what I understand, has a little more of that sort of one layer abstracted view on things.
I found myself with Terraform a lot of the time. I have to build like initial infrastructure, i.e. like a phase. Then I do additional infrastructure and then environments like that where there's different states of different complete ecosystems.
Yeah.
Then I end up with like tons of multiple phases in workspaces, which can be self-management, convention-based kind of pseudo-nightmare.
Right, because then you have to issue a command, Terraform Workspace, select or whatever?
Yeah.
And
basically
batch glue.
Like,
yeah. So, yeah, it's a really cool thing. It's a chicken and egg issue.
TerraGrunt comes up a lot, but I haven't gotten with it.
Yeah, it is next on the menu. Next course.
I mean, in relation to that, can I ask kind of a stupid question? It might show some of my deficiencies, but I mean, you're basically talking about having problems spitting out new accounts underneath an organization, right? Because I mean, what I've kind of had some experience with lately is like the landing zone concept, where they're pushing that out with cloud formation when they're kicking out new templates and
right.
Saying, hey, all your CloudTrail logs go to the different accounts, there's config rules and that kind of stuff. But are you saying that basically there's a problem that you're having with account provisioning, and then you need to get that construct going before you can actually use Terraform to build what you need to build inside of it? Or?
That's some of it. The other bit is that say you have. Okay, so there's a great video, I forget who did it, but it walks you through the stages of Terraform, where it starts with the Terralith, and you have one state file, one module, and all of your infrastructure. Everything. I mean, shoot, you could go organization down to accounts, to VPCs, to instances, to EKSs, and all of that. And you could have all in one state file, so that anytime you run Terraform plan, you got this huge plan. And if that state goes bad, your whole thing, you need to do surgery on the JSON file, right?
Or if like the account provisioning service principal or whatever gets yanked somehow.
Sure.
And disassociated, then you got to remap that stuff. That can be a whole, heaven forbid you have to like infer what's out there because your state's out of sync all of a sudden. Right. You almost better just wipe it and go next thing. Yeah. So then it walks you through this talk. I should find it and maybe post it, but it goes through TerraMod, where you have modules and you get very modular things, and then you get to Terra Services, where you stand up a service and you have a little state file that can then be used remotely, like a data source for another service. So these services sort of loosely depend on each other. There's a little loose coupling, but it's not that if this service goes sideways and you screwed it up with Terraform, you could just wipe that away and all this rest of your infrastructure is still good to go. So a lot of these issues are that how do you, with one repo, for example, deploy several of these loosely coupled services and have them reach into each other's state and all the way down. Not impossible to do, but it just gets gluey, is what I was saying. Although
you want to break it up to kind of reduce some of your blast radius.
Right. And so you end up automating it with, CD here, CD there, Terraform apply, that kind of thing.
Any other questions?
Actually, one other question I had was like where I work, we'll use App Dynamics for a lot of stuff. And
Yeah.
Expensive tool, but one thing that's helpful is that I've triggered I've put a lot of alerting depending on the baseline, because the baseline changes throughout the day.
Right.
Like one of the dodgy financial applications that I work with, it kind of has a kind of quote-unquote warm-up period. The thing is that you'll have a lot of objects being cached in memory during that, when everybody's logging in at the beginning.
Right.
So the performance is really crappy.
Yep.
And then all of a sudden it kind of levels out. And so, if I have triggers like at 200 milliseconds or 400 milliseconds, that'd be relevant you know, at the beginning of the day, but in the middle of the day, it wouldn't be relevant. I mean, have you ever, I mean, in kind of the construct where you're trying to pre-provision like that, is there any, like with Datadog as a tool, is there any way to, you know, take in that kind of like baselining and alert off of that, or is it really just kind of knowing your app and really having the metrics ahead of time before deployment?
Well, if you're talking about just monitoring, there are ways to use some anomaly detection. Datadog's got that. That's kind of the secret sauce, I think, because they've expanded that into Watchdog, which can look at your traces and your infrastructure signals and just automatically say, hey, this is unusual. Using some machine learning and predictive statistics, you can say this CPU utilization just went from a normal 40% to 80%. So that's seeing it. Now your question, it seems like more to me, is that how do you deal with that operationally? How do you make that so that you maybe pre-provision, scale way out at 6 in the morning, so when people log on at 8 and 7, you've got multiple workers taking those requests in. That's where looking at your system's choke point, your bottleneck. You know, how do you scale out your bottleneck? How do you decouple it? Can you use message queues? Can you take a bunch of requests and give people a certain amount of progress, all while you process that backlog asynchronously, and then get them back to eventual consistency? You know, is that an option? I think that's where things are going these days, is decoupling as much as possible. But you have to give something real at the other end, right? You can't just decouple and give them some sample page. I don't know.
I was just getting more at a unique situation I had to deal with where behavior is inconsistent, so it's difficult to set targets.
Oh, I get you.
When behavior is bad, because bad behavior is defined differently at different points in the day But I mean,
I hear you.
That might be into more of the application performance monitoring, which we're
Would you paraphrase that as saying, is it possible to monitor with knowing the date and time?
Right, like a piecemeal function, right? Where you've got like, during this time of day.
Like the triggers are set to say, hey, 2 standard deviations out of
Right, like 12 a.m. to 12 a.m. and noon's here. And you've got, you know, traffic like this. And you're like, hey, through here and here, I want this threshold.
Yeah.
And then between these hours, I'm okay with here. Or no, I want to be triggered here. Right, so during this period of time, this is my threshold. During this period of time with that. So you can have outages in monitors, you can set them to, actually one of the dudes at Nordstrom was doing this thing where he would, it was one of the agent checks, and so it was like a little Python script, I think is what he was doing. I forget what he was doing, but he was doing this nice little logic gate, basically, where he would say like, you know, if he was testing like even and odd hours, if the hour of the day was even, it would block, it would essentially null out that monitor from tripping, right? And he was getting that to work so that the monitor would only show up every other hour. And so he was starting to work towards, hey, what if we had that for the cash registers? Because they're not seeing any action all night long. But then, you know, during the day, you need to know what their status is.
So I have 2 things to say real quick. One, we should keep talking about this over beer.
I like that.
I have more questions and thoughts and opinions.
You look like you're in schoolboy mode there.
I am in school. I'm not here listening. Student.